Many outcrops in the exhumed roots of ancient mountain belts, and young ones too, contain deformation structures that can at first sight appear both beautiful and bewildering. Approaches for developing an understanding of these types of rocks were developed here and formalised in the 1950s by John Ramsay. These outcrops lie on the shores of the reservoir of Lochmona and contain spectacular outcrops of folds. The rocks themselves are samites, they are meta-sandstones, and you can still see the layering, bedding picked out in the outcrops. Let's look at this structure first. And probably the most obvious features are these fold structures which are running up and down the photograph. But let's look at the layering a little bit more carefully. The primary layering comes back on itself. Here are just a couple of examples picked out by the white and by the green line. These are both folded, so let's trace out the axial surfaces for these folds. Here's the first one, and you can see that it's folded by the structures we picked out already and denoted with the red lines. What about the other fold structure? This runs through here, folding the green horizon, and you can see that as this fold structure, picked out by the yellow trace, runs out to the right-hand side, it gets completely squashed out and almost obliterated in a zone of rather more intense deformation that we've just picked out here. So let's try and understand these sorts of patterns. So here's another outcrop photograph, but let's start off messing around with some paper. So here's a stack of paper sheets, and at the moment they're not folded. Well, let's just fold these back on themselves to make a recumbent isocline like this. And we can pick out the axial trace of this fold. We're looking down the hinge line of it, and you'll notice that the axial trace only crosses the layer at its hinge point. This is an important rule that we'll use later. Okay, so that's one phase of folding. Let's fold our paper again around an upright structure. And you'll see that not only is the paper, the layering itself folded, but also so too is the earlier axial trace. We describe these distinct folds as F1, the earliest fold, and F2, the later fold. The later fold has a simple form. The axial trace of the F1 fold has a more complicated shape. Okay, so let's use these ideas and have a look at the structure at Lochmona in the photograph on the left. We won't worry too much about those little veins and making all those rather spectacular little squiggly bits at the top of the photograph. Let's just consider this dark layer. Now, as we trace it to the left, it seems to wedge out here. Well, we'll think about that in a minute. But you'll notice the boundary of the dark layer is itself folded. And we can trace out these folds across the layer itself. Like this. There's a whole series of fold traces running across the photograph. But what about this termination? Well, the boundary of the dark layer inflects around that point. So the dark layer itself and its boundary have folded around an earlier structure which we've labelled F1. The axial trace of the F1 fold only crosses the interface between that dark layer and the surroundings at the hinge point marked with the yellow dot. Critically, the F2 folds deform the F1 folds, just like we saw in our paper exercise on the right-hand side of the screen. Well, let's take these concepts and apply them again, but we'll move away from Lochmona and we'll go to an outcrop in the Italian Alps that's been sketched out here in this notebook sketch. And our task is to interpret the fold pattern. The sketches of some metasedimentary rocks and the stippled layers that are picked out on the sketch represent thin sandstone units. Okay, when faced with an outcrop like this, it's always best to try and start in the places that appear the most simple. So we'll pick out a few simple fold hinges, join them up and show their axial traces, and we can see that these axial traces picked out by those purple lines incline from right down to the left. Let's see if we can find some other structures in a similar orientation. So we can identify another fold here, picked out with its axial trace in purple, and we can find maybe some more over here. So we've got an array of folds where the axial traces are inclined from top right to bottom left, and we pick them out here. We've not completed the interpretation because there are a few terminations and closures of layers in here that need explaining. Here they are. These represent hinge points, points of maximum curvature on the boundary between the stippled and non-stippled layers in here. So let's use this rule that an axial trace can only cross a layer at a hinge. There we go. So now we've got two sets of folds, a whole array of folds with axial traces picked out in the purple lines, and one other fold in here, an earlier generation fold, and we picked out its axial trace like that. So the blue axial trace is folded, the purple ones are simple. Consequently, we can infer that the latest folds are the simplest ones, so these denoted F2 here are represented by the purple axial traces, and the earlier phase here, labelled F1, is picked out by the blue line. This axial trace is folded around the F2 structures. So we can interpret a relative sequence of folding. So let's go back to Lochmona. This is a classic view of domes and basins. We can pick out a set of axial traces running like this with the red lines, and another set running across the photograph at almost 90 degrees to that red set. In 3 dimensions, the layers that are folded in and out of those folds represent domes and basins, rather like a set of eggs in an egg box. So you can imagine the journey taken by the fold traces on here, the yellows and red lines, and those axial traces run up and down over the eggshells, both in the yellow set and the red set. If you imagine slicing the tops of the eggs off and look down on the pattern of the shell, it'll create patterns rather like the layering intersecting the surface of the outcrop in the photograph. The challenge is to establish what the relative timing of these two sets of folds are. Because they are orthogonal, diagnostic refolding patterns are not developed. Let's turn to this exposure, again at Lochmona. We'll just consider that bat shape here in the photograph. We can identify some structures running more or less up and down the view, like this. Here we're just picking the downward closures, the synforms, to avoid cluttering the diagram too much. But even so, we're only partly interpreting the outcrop. There are also a couple of closures here that appear to be isolated. Let's link these with another axial trace, and this time we can see that the yellow line on here is significantly more complicated than the red lines, so that the fold represented by the yellow line presumably came first. So in this case, the relative age of the two sets of folds is resolvable. So if you scout around the shores of Lochmona, you can find a variety of outcrop patterns which represent the interference patterns of different sets of folds in different orientations. You can explore these patterns by folding pieces of paper, doing some structural origami. But let's move on and leave Lochmona behind and go up to the north coast of Scotland, to these rather spectacular outcrops, which also represent deformed metamorphosed sandstone sequences. Let's try and pick out some layering. And we can see some really remarkable patterns in here. Now let's try and pick out some folds. So these are the axial traces running through the outcrop, or at least some of them. We can see that the white set running through here which are effectively recumbent, have a simpler form than the red set. Indeed, the red set of axial traces are folded around the white set. So we can infer a relative timing, that the fold closures along the red series are earlier structures compared to those formed on the white. So we have a systematic approach by which we can try and tackle an outcrop. There's no need to stand back and scratch our heads in bewilderment. The trick is to carefully trace out the primary layering and identify hinge points, and then try and construct through the axial traces joining these hinge points together. We can then interpret the sequence in terms of the complexity of the axial traces in the outcrop. Once we've done that, we can of course add measurements. These sorts of analyses are classical in structural geology, and having done all this work, we can then debate as to what the tectonic significance of refolded folds might be.